Hi everybody, my name is BorisFlotterer. I'm a PhD student in French, and today I'm going to present you some results of my work. Oh, here it's better. My supervisor are Cédric Gaucherel from AMAP and Christelle Elie from ISEM and EPHE. First of all, I want to come back on the definition of what is an ecosystem. We take the definition of an ecosystem of elements, different type of elements, biotic, abiotic, and anthropogenic, and is the interaction between these different components of the ecosystem. And we take the definition of the socio-ecosystem because we split the anthropogenic components and the biotic components. Normally, anthropogenic components are biotic components. For made my model step by step, we prefer to split them in two different parts of components. Now I want to come back on the definition of metaecosystem. If we take the metaecosystem and just continue the definition of ecosystem, a metaecosystem is different ecosystem of the same nature. For example, if I take boreal forest, we can have mixed wood forest or black spruce forest on field moss. And there are two types of boreal forest and they can have interaction. And you can have an external factor like climate or neighborhood ecosystem have an impact on those ecosystems. What is important is in this definition, you have different patch of ecosystem can disappear and appear. And I try to model this type of dynamics. This type of dynamics are theorized by Javito in 2001 and named Dynamical System on Dynamical Structure. The explanation is very simple. The system can have an impact on the structure and you can have a feedback of the structure on the system at the same time. For trying to model this, I take a tool in informatics named the graph transformation. The particularity of this model is are discrete, possibilistic, and qualitative, and asynchronous too. I try to integrating biotic, anthropogenic, better like this for biotic, anthropogenic components and their interaction. For do this, we need a triplet of elements. The first one is a set of components with all the components of my meta-ecosystem. The second one is the rules are created with some bibliography and review and take about the knowledge, the actual knowledge of the meta-ecosystem. And the third one is an initial state to initiate all trajectories and scenario we can have in the model. The first objective of my first chapter it's try to see if with my model, I can have the three different types of forest and the mechanism of three different types of forest. What is interesting here, we can see you have black spruce forest on field moss and mixed wood forest are really mixed in the geographic space. And you have a real clear better limit, more clear limits between black spruce woodland on lichen and black spruce forest on field moss on the north. And I want to see if the interaction and the comprehension of the ecosystem with my model can explain the difference between these three types of boreal forest. First of all, I try to do just natural forest dynamics without the anthropogenic. I take the two natural disturbance, the wildfire and the outbreak of the spruce bedworm. I do my model with some rules. I have some state space and trajectories, and I want to compare them with paleoecological record for make some validation. For this, my initial state and the model I choose, I want to take the initial space of the post-glacial condition with all the species are present in the neighborhood of the proglacial lake 8,000 years ago. And when the glacial lake emptying, the seed can spread and the trees can colonize the bare soil. I take 5 species for beginning, 5 species in the boreal forest, more important in the west-east part of the east part of Canada. Trembling aspen, balsam fir, white cedar, black spruce, and jack pine. And for the really initial state space, I take some bare soil patches, look like just a lake after it is emptying. If I do my model, I have some type of result, look like this. It's a full state space with all arrow represent a transition and rules, and I make different rules, and you can see 4 types of rules. In green, the vegetal succession and the vegetal growth. The second one is the spruce budworm outbreak in purple. In yellow, you have the surface fire, and in red, the crown fire. And what is interesting to see, it's with this model, we can see the different type of forest. On the right, the mixed wood forest. On the top left, the black spruce forest on the fissimost, and on the bottom left, the black spruce woodland on lichen. And we have the 3 types of forests in this model really separate, and this is interesting. Another point interesting is you have a tipping point in the black spruce sapling most, because you can see this red arrow, it's in a unique direction and you can come back. And it is interesting because in paleoecological data and in review, a lot of time when you see black spruce sapling on lichen, you don't have to come back on other type of forest, and you stay in black spruce woodland. Now I try to make some paleoecological validation. Here in blue is the visible process or state we can have with the paleoecological records, and in black is the invisible process. For example, if you have growth of some trees, you can see the growth. You can see if the trees are here or not with some pollen, with some charcoal, macro rest, remains. Sorry, and is the different thing you can have. Now, if I take an article of Silmar in 2006, you can see some trajectory. I take just one for the example. For example, here is you have charcoal. After you can see the outbreaks of spruce budworm, and new charcoal represent the crown fire. And the trajectory is crown fire, outbreak of spruce budworm, and crown fire. And if I try to see if I have them in my model, you can see you have different possibilities. With the one here represent a crown fire in green and red. The 2 is outbreak of the spruce budworm, and the 3 a second crown fire. What is interesting to see, it's with one paleoecological reconstruction, I have 2 different scenario and trajectories in my model. It's why I think it's interesting to find an initial state space in the paleoecological model to try to have more information about my model and improve my validation. And it's why I try to do now. Now I do a second model. The second model is the modern forest dynamic with some forestry, with 2 different types of forestry. The first one is just only clear cut, the traditional forestry before the 2000. And the second one is after 2000. And is the sustainable forestry take care about the regeneration of the sapling. Same, I have a state space and trajectory. I try to compare them with forest cover, forest data, and some data we can have today, and try to see if my model is correct. Now, if I see the result, this is the result of traditional forests. You can see the same state space as before, but you have just 2 brown arrows more. It's the arrow representing the forestry and the different type of cut you can do in traditional forest. And what is important to see here, you have the first one go in the black spruce to the moss, and included some problem of regeneration, because if you have moss on the soil, you have some problem of regeneration than the bare soil, when the seed can just grow more and faster. And the second one is the black spruce moss to the black spruce sapling. It's just you don't have problem of regeneration, but the other problem here, it's you go to the tipping point. And if you go in the state of black spruce sapling moss, you have some crown fire, you can go in the lichen state. And lichen state is it's one of the tipping points, because you go in the black spruce woodland on lichen, and it's irreversible state. The second result I have is the same model, but this time with the sustainable forestry. And we can see we have 3 arrows this time and no problem of regeneration on moss. You have already the problem of the brown arrow on the bottom of the black spruce moss to the black spruce sapling go to the tipping point. But this time, the black spruce moss state, when you cut, you made some you cut the moss too and just destroy the moss in the soil to go to the bare soil and don't have problem of regeneration. Or when you have black spruce on moss, you can just take some trees and not everything to have regeneration of the trees, but without everything cut, just some trees. And this model are interesting to see. You can represent the actual forest in the model. What I want to do in the third part and my third chapter is test new forest management, try to have new idea of management, and try to test the new forest management in the model for after, try to establish the new forest management after the test of my model. Thanks for your attention.